Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about with this structure the above reaction are summarized as follows. Finally, the structure determination of the citral, starting from there are the various steps we have discussed. First one is a molecular formula, second one is a detection of unsaturation, third one nature of acyclic nature of that citral. Then after that we have seen nature of the oxygen atom. It is involved in the various functional group such as hydroxyl group, carbonyl group, acetyl group, oxo group, carboxylic group. In that way we have learned. After that we have seen position of that aldehyde group in a citral, and also we have learned that aldehyde group also present in the conjugation form, and then we have seen oxidative degradation from in the alkaline potassium permanganate in presence of CrO3, as well as ozonolysis produce the acetone as one of the common example, and from that by analyzing the degradation product we confirm that there is a position of carbon-carbon double bond conjugation is there, and by summarizing all these reactions together we derived the final structure of that citral by carbon framework, how it is applied, how it is follow that special isoprene rule, and finally we end up with the structure of that citral is that one. And after doing all these reaction together, and finally we carried out the different reaction on it, and we got the different type of the product. We consider that this is a structure of that citral, and we carry out reactions such as a reduction reaction, sodium amalgam in presence of dilute HCl we got as a zeroanyl. Then we carried out the oxidation reaction, we got as a zeroanic acid. So like that we arrive finally, and the final structure of citral is confirmed by its synthesis. Now the synthesis is very important for 3 mark. The question may appear in the exam, either this one synthesis of citral or synthesis of ephedrine. Out of these two, one must be there in the exam. So remember, this is the now we have given synthesis of citral, and this synthesis first time carried out or synthesized in the laboratory starting from the known compound. The name of that synthesis is a very well known, that is a first one here, that is a Barbier and Boult synthesis. Barbier and Boult synthesis. Barbier and Boult Boult synthesis. He synthesized this compound in 1887. This is the year. In this year he synthesized this citral, synthesis of citral, that name of that synthesis. So give the synthesis of citral or discuss the Barbier and Boult synthesis. So Barbier and Boult synthesis is nothing but as a synthesis of citral, and what he had taken, how he synthesized that citral. Let us see first one. First one is known as a 2,4-dibromo 2-methylbutane into methyl heptanone. 2,4-dibromo 2,4-dibromo 2-methylbutane into methyl heptanone. This is the first step. These are the starting material he had taken for the synthesis of the citral. What is that? 2,4-dibromo 2-methylbutane, but indicate as a 4 carbon atom in the straight chain. So we can write this one Br in this manner. Then let's see over here. This one is a Br. And look at, this is a structural one, not this one. Let's me give the number here from 1, 2, 3, 4. So at 2 and 4 position there will be 2,4-dibromo. At 2 position methyl group is there, 2-methyl in the straight chain, 4 carbon atom is there, and therefore butane. That is the IUPAC name of this compound. And what we have to convert this into the methyl heptanone, and this reaction further carried out with this compound. First one C double bond O, then CH, Na, that is a minor charge over there and positive charge here, C double bond O, this methyl group. The name of this compound is a sodium acetyl acetone or soda acetyl acetone. This is the starting material he has taken for the synthesis of that compound, and now condensation reaction takes place. Condensation means what? This negative charge is going to attack on this electrophilic carbon atom, and there is a departure of bromine atom, so that you are going to get over here C double bond O. Then I am writing like this, and now this one. So here this Br, for the suitability I am writing as this type of the compound. Only we form the bond between this carbon atom and this carbon atom, we got this compound, and finally we can treat this compound with sodium hydroxide. This bond is going to break over there, acid on the one side, and then there is a what we can call it as a dehydrohalogenation takes place. So this will be the removal of the HBr over here, and finally you are going to get the compound, this one C double bond O. Then this is the compound which we got. If you remember this one again as a 1, 2, 3, 4, 5, 6 and 7. So at 6-methyl 2, that will be the IUPAC name of that compound, is a different one over here. So here you can call it as that one, but here just remember as a methyl group, heptanone. Methyl means what? Methyl at which position? So we can write 6-methyl, then hept means what? 7 carbon atom in the straight chain, then 5 at 5 position En, and at 2 position One. So that is the IUPAC name of this compound, or you can simply remember this is a methyl heptanone. One indicate as a double bond is there, and En indicate as a this 6-methyl hept 5En 2One. That is the correct IUPAC of this compound. This is the in the first step what we did, we got the methyl heptanone. Understood this one? Now is a methyl heptanone into citral. Second point we are going to see over here. Second one is this one. Let me clean the board first, and then we are going to write that one. That is this one. So what is that? Methyl heptanone into citral. B part is a methyl heptanone. Methyl heptanone into citral now. Citral, right? Now this methyl heptanone we are going to take as a starting material in the second step. Let's see here. Let's have that methyl heptanone structure. We know that this is a structure of methyl heptanone, right? This is a structure of methyl heptanone, or what we can call it as a 6-methyl hept 5-en and 2-one. That is a methyl heptanone. Methyl heptanone. This is a starting compound, and when this starting compound treated with zinc dust in presence of this one CH2I, then C double bond O OET. That is alpha iodoester. Here you can call it as alpha iodoester. It is one of the famous reaction. That famous reaction you can mention on the arrow. That is a Re-Farmansky reaction. Re-Farmansky reaction. This is a very famous reaction for the alpha hydroxy ester. What you are going to get over here? The compound you are going to get here OZNI, then C double bond O ET, and here other part remains as it is. What is going to happen? This is going to here form as a negative charge, that is going to form as a here. So in this way we will get as a this one, and after that you can acid hydrolysis. After the acid hydrolysis, what do you get? Here you carried out acid hydrolysis. Acid hydrolysis means here hydroxy group is come over there, so that you will get OH over here, rest of the thing as here ET, and then other part remains as it is, like this. And this reaction further carried out with AC2O, acetic anhydride, heat it, acetic anhydride, removal of water molecule takes place over here in this manner. One H from here and OH from here, so that you are going to get here double bond, then finally here you will get COOET, right? That is a ester group which we got over here. And after that, first one, this is first treated with, let me clean over here. So first one is a hydrolysis and lime. First one is hydrolysis, and second will be the lime. Lime means calcium oxide is nothing but as a lime. After adding these two step on this particular, so what you are going to get? You are going to get here this double bond, then this part remains as it is, and finally here the COO, then you bracket it calcium twice, and after that you can do the distilled. This one is carried out with this distilled with formic HCOO twice calcium, calcium formate distilled. So what you are going to get? You are going to get finally this type of the compound CHO. This is nothing but as a citral. So in this way finally we can obtain this citral by using these various steps. So what is important here, you have to remember as what are the starting material he has used for the synthesis of that citral. So the name of this synthesis is a Barbier and Baumol synthesis. Describe the write notes on, or what we can call it, describe the Barbier and Baumol synthesis. So you remember that is the synthesis of the citral. There are the two steps are mainly to the starting material he has chosen, he had taken is a 2,4-dibromo 2-methyl butane, and he converted into as a methyl heptanone. How it is converted, that we have seen, that is a 2,4-dibromo 2-methyl butane treated with the soda acetone. Condensation reaction takes place, we will get the intermediate, that intermediate further treated with the sodium hydroxide, and the resulting compound is obtained is called as a methyl heptanone. That is the first step. See, in the second step, methyl heptanone into as a citral, and he has taken the starting material. Now here is intermediate which we got the end product in the first step, which is used as a starting material in the second step. So what is that? That is a methyl heptanone. The IUPAC name of that methyl heptanone is a 6-methyl hept 2 5-en and 2-ONE. That is nothing but as a methyl heptanone treated with the zinc metal and the alpha iodoester, and this is one of the famous named reaction, that is a T.Y.B.Sc. reaction, so that the resulting compound intermediate is obtained, and that is hydrolysis. After hydrolysis we will get as a beta hydroxy ester, which is the T.Y.B.Sc. reaction, and this beta hydroxy ester further treated with heated with or boiled with acetic anhydride. There is a removal of hydrogen water easily and form as a stable one alpha beta unsaturated aldehyde, and the alpha beta unsaturated ester, and that ester further hydrolyzed, and treatment is given with that. Lime is nothing but as a calcium oxide, and we will get an intermediate. That intermediate is a calcium sort of that acid we got, and further it is distilled with the help of calcium formate. The resulting compound is obtained as a pure citral. So this is one of the what we can call it as a method. It is the best method, and this method is invented or discovered by that scientist in 1887, and that's why name is given to that reaction. Synthesis of citral is a Barbier and the Baumol synthesis. I think this is the part we have discussed over there. In the next time, half of the chapter is over here, half is remaining, that is the second part is alkaloid. Whatever we have learned, this is about the terpenes or the terpenoids. What is that terpenoids? And one suitable example we have seen as a citral with their details. So in the next segment, in the next lecture, we are going to learn about the alkaloid. What do you mean by the alkaloid? Their introduction, everything we are going to learn in the next lecture. And with this, let us stop today here. Remaining we will see in the next lecture. Have a nice day. Thank you.